In this lesson, we're looking at using the three ratios, sine, cosine and tangent, to find a side length in a right angle triangle. Now remember, they have to be right angle triangles. And what we use to remember this is SOHCAHTOA. Our first step when we are trying to find a side length is to always label our triangle. So remember, the side opposite the angle, the given angle, is the opposite. The side across from the right angle is the hypotenuse. So what information do we have? Well, we have theta is equal to 30 degrees. We have the opposite, which is what we are looking for. That's our x, and the hypotenuse is 2. Well, what do you now use? SOHCAHTOA. Angle opposite hypotenuse, sine theta equals opposite over hypotenuse. Put in the information that you've got. So sine of 30 degrees is equal to the opposite, which is x over 2. And now with the unknown up the top, x is divided by 2. We're going to bring the 2 across by timesing. So 2 times sine of 30 degrees is equal to x. So what does x equal to when we put it into our calculator? X is equal to 1. Let's have a look at the next one and do exactly the same thing. We're going to label our triangle first. So we have here across from the given angle we're not looking for and we don't want, so let's not worry about that. But we do have the side between the right angle and the given angle, so that is our adjacent, and the one across from the right angle is our hypotenuse. So what information do we have? We have theta is equal to 25 degrees. We have the adjacent, which is what we are looking for, our x, and our hypotenuse is equal to 5. So again, we ask ourselves, what is the rule or the ratio that we can use? SOHCAHTOA. Angle adjacent hypotenuse would have to be cosine, or cos theta is equal to adjacent over hypotenuse. Notice how I keep writing the rule so I remember, and now I'm going to substitute in. So I get cos of 25 degrees is equal to the adjacent, which is x over 5. And again, you can see that our unknown's up the top there, and to get x by itself I have to times by 5. So 5 times cos of 25 degrees is equal to x. So when we put that into our calculator, we get x is equal to 4.53. That's 2 decimal places. Now if you're getting the wrong answers, perhaps your calculator's not set to degrees. Okay, so make sure that your calculator is set to degrees. The other thing is, there's a good way of checking that you're in the right ballpark here. We got x equal to 4.53, and we know our hypotenuse is 5. What we do know about the hypotenuse is that it should be the longer side, so it needs to be bigger than the answer we got. So it is a feasible answer. Not necessarily right, but I can assure you it is, but it is a feasible answer. Okay, last one. Let's do the same thing. Let's label our triangle again. So again, directly across from the given angle, I have the opposite, and between the given angle and the 90-degree angle, I have the adjacent. So what information do I have? I have the angle, which is 60 degrees. I have the opposite, which is what I am looking for, and the adjacent is equal to 3. What's the ratio I use? SOHCAHTOA. Angle opposite adjacent. It has to be tan, doesn't it? So tan theta is equal to the opposite over the adjacent. Let's put it in. Tan of 60 degrees is equal to x over 3. And now let's move the 3 across by timesing. So you get 3 times tan of 60 degrees is equal to x. And when we put that into our calculator, we get x is equal to, now remember, 2 decimal places. So 5.196 becomes 5.20 to 2 decimal places. This time we've got no idea whether it's feasible or not because we weren't given the hypotenuse, and either of those two sides could have been the smaller side. So that is finding the side length in a right angled triangle when you're given an angle.